All right, so close your eyes. Trust me, close your eyes. I'm about to show you something, and the first thing that pops to your mind when you see this thing, give it 10 seconds, and then share with your partner what comes to your mind when you see this. Ready? Go.
I like that. There you go.
All right, what do you say?
3 seconds.
You see 3 sevens, and in your mind, that connected to anything. You just solve
3
it.
divided by 7.
3 divided by 7. All right, what did you say? I want to hear this one.
Work 3 days out of 7 days in a week.
Cool.
That's a good lead.
Monday, Wednesday, Friday. Is that your schedule? Monday, Wednesday, Friday? 3 sevens? Oh, you have a thing.
Well, you wanted me to share. I was thinking of a pizza cut in 7 slices, a septagonal pizza, and I wanted 3 slices.
So 3 divided by 7, 3 out of 7, 3 out of 7 really is how you saw it. Anybody else?
Well, I saw it as cutting up a square block into 7 equal pieces, and I'm going to only look at 3 of them.
Slope of a line.
Sort of a 3 out of 7 as well.
Slope of a line.
Rise over run.
Rise over run.
Yeah. Slope of 3 sevens for some reason. Yeah. Good. All right. So a lot of times, the part to whole model, 3 out of 7, 3 out of 7, 3 out of 7, is sort of the most prominent way of thinking about this fraction, 3 out of 7. And that's fine. It's correct. It's good. But it's not complete. Because if you only think about 3 out of 7, how are you going to interpret 7 thirds? 7 out of 3. I cut the pizza up into 3 slices, I took 7 of them. I cut the block up into 3 equal pieces, I took 7 of them. Right? I have 3 days in the week, I work 7 of them. That's how it feels. In fact, when students do this, research would say, when students see 7 thirds, they say one of 2 things. You can't do that. You can't have 7 thirds. It's impossible. Or they just see it as 3 sevens. They just flip it over in their mind and go, oh, that's 3 sevens. That's what I'm going to do. They cannot conceive of 7 thirds. Or what about this? How are you going to do a problem like 8 divided by 3 sevenths then, for these students who don't think, that if 7 thirds doesn't exist, how are you going to do 8 divided by 3 sevenths, right? Sometimes people will see a ratio. They'll say, kind of like a slope, right? A slope is sort of a ratio. So there's 3 boys for every 7 girls. Some people would say that. I didn't hear that one today. But when they say that, it's good, it's right, it's fine, but there's an implied multiplicative relationship that it may not really be there. That 3, 7, it may not be literal, 3 boys to every 7 girls. What if there's 14 girls in the class? What does that mean? Well, there's 6 boys. Did I do that right?
Yes.
I would have to check my computation. But the point is, when we see ratios, we may not always fully unpack all the meanings that are there. And then 3 divided by 7 is another one that often comes up. But my contention is, that doesn't tell the whole picture about what fractions are. So what I'm going to have you do now is find out what are fractions really all about. So in your packet, I'm going to give you the packet now. And in your packet on the first page is this. And your job is, suppose that this bar right here represents 3/8 of something. Can you construct a bar, given that that's 3/8, can you construct something that's 4/3? Based on that 3/8. So I'll give you some time, you can work with your partner, you can throw out ideas, you can make conjectures, you can throw dendrites.
Just tell me how to do it.
You never showed me how to do that.
Enjoyed it. Thanks for letting me play.
Yeah, absolutely.
I'm going to send Brad.
Yeah, we did.
I would do 1 is to 3 over 8. As how many is right? One bar is 3 over 2. I'm sure you I think whatever you want to do is fine. Okay, so I like your thinking there. Okay, so up here I have the bar is to 3a equal to x is to 4. Okay. I like that. That's the first thing I got. Okay. So 4/3 is to no, it's 3.
You like that?
So is this 4/3, or is it 4/3 because this is 4?
Yeah. Go ahead. They're cross multiplying.
This is 3.
No, you're fine, I dropped my half. So 30 is 29.
I've never done it that way.
Equals the number of bars.
Yeah, I know. And this bar is 3, okay.
Represents 3/8.
Yeah.
So that's
So-
this bar.
Why am I focusing on child?
Well,
I like the way she thought. Even here, so she's saying one bar is 3a.
that's right.
And so we need to find out how many bars per meter.
So how many of these? Okay,
Right.
so it's how many?
So then it's 32 an hour.
So you need to make 3 of these.
And then 5
Now,
next.
how are you making 5?
But that's the part of the whole, is
Because we want you to, we want you now
So how do I
to
take
rule
that,
the
make it
bit,
4/3?
but just sketch
It
it.
doesn't say.
You're gonna now sketch.
So the
You
first
take
bar
one,
is
two,
a bar
three,
is
three.
equivalent to 4.
1, 2,
Okay.
3.
This bar is.
But then we want you to actually sketch out the remaining 5 lines.
Okay.
So this is now just 4/3.
Okay.
What's your idea?
Alright, so
Okay, wait.
this is 3a.
So what do you want me to do with that? Because I just didn't.
Well, you know how many of these you need, right?
3a.
So you need 1, 2, 3 of these things.
This is
And
3a.
then you need to make another.
Okay, so right now I have 3,
Like, it's a
6,
sketch.
9, 8.
If you're gonna sketch out 3 of them, that's easy enough. But now, how are you gonna sketch out 5/9 of it?
Yeah, so this is.
Okay, and then I need 5 9.
Do I split my bar?
I would say so.
Well, here, this is how I visualize parcels. So this represents 3/8, then this blue part was a part of the silver part. Right, then how do I fix it? Right, like a little scan bar. If it's a 4-inch scan bar, take one of the 5
Well, we want you to construct 4/3.
Okay, so then this is 5, 9, 3, and so that's
4/3. Same bar, same length, same floor size.
Right, so it'd be 45 minutes.
This is
Third, so therefore.
Oh, man.
Without
So I
changing.
have this
We want this to stay 3/8.
plus this
And this is 3/8.
plus
Like
this.
another one of these would be 6
So then if we get our common denominator, just double check
We
right
want to
now
build
it's
something
correct.
that would literally be.
So it'd be 72, so then it's 9, 9 here, and then it's 9.
You can't make it a new. Not much. You can, I know. That's not.
Okay, so the progress, we're saying that this is
It's gonna stay pretty close. That's 3/8.
1.5.
This is a whole, well, before I was looking at it, at least that.
Oh, because it's 5 9 of 3
You know, I don't.
I don't like your answer.
Times.
I like mine.
Yeah.
Right.
And it's multiplied to the right. So, right, the 3, and I didn't simplify the other parts. They could have, and that probably would have made this whole process easier, I just didn't. Because I would make.
So this is.
we add each one plus.
15 is nice.
Hey everybody, we have
Winner.
a winner. Sue is just really excited to share.
This is really cool what you did.
How come it's not letting me switch though?
There's a 30-second delay.
Broken and left.
No, it's usually that way.
What were you doing before to change slides?
Well, no, then I need to change the document camera.
Oh.
Did you unplug it, plug something back in?
Just use the whiteboard, yeah? Alright.
Oh,
Don't let technology hold you back.
I'm actually used overhead last week, Scott. Yeah, I can ask you possibly.
All right, hey, now wait, before you go, Sue, before you go. One of the things I try to train my students to do on a daily basis, especially now kind of early in the course, is, you know, you have this opportunity to work and think and talk to your partner, and in my class it becomes a problem that they become so friendly with one another that they don't really then want to turn their attention to somebody else, me or anybody else. So we have to do a little training now where I say, all right, stop everybody. Part of this dendrite growing thing, by the way, I give them the whole dendrite lesson. Part of the dendrite growing thing is you must learn to listen and reason and critique. And we're going to allow that to happen in my classroom. Critiquing one another can happen professionally and constructively. So when we say critiquing, it doesn't mean, you're dumb. It's just, we're going to talk about what you did. So here's that opportunity. Your job now is to listen to Sue, try to reason about what she's saying, connect it to what your experiences, what you know, what you think, and then when you're done, we'll have the opportunity to maybe ask questions or critique or whatever, okay?
Okay,
So go ahead.
so you have this bar, is that what it's called? A block, bar?
I think I called it a bar.
And it's 3/8 of a bar. So if I've got 3/8, I'm just gonna create the other 5 pieces, 5/8 of it to make it a whole. So I just